Hello, I'm Seema and welcome to part 3 of the chapter Haloalkanes and Haloarenes. In this video, I'm going to talk of the nomenclature of this class of compounds. In class 11, you have studied about the Iupac nomenclature of all hydrocarbons, and you've also studied to a great extent the common nomenclature and how it is done. I would encourage you to watch those videos before you come to this video, because this is nothing but an extension, or rather a little further study of one of the class of compounds whose nomenclature we are going to do, and that is haloalkanes and haloarenes. So not wasting any time, I would like to start with the topic, assuming that you already know what you have studied in class 11. So let us move ahead from there. We know haloalkanes and haloarenes are those compounds in which a hydrocarbon, one of the hydrogens of a hydrocarbon, has been substituted by a halogen atom. So in common nomenclature, they are normally called as alkyl halides. You know, whenever you remove a hydrogen from an alkane, that group is known as an alkyl group. And if you put a suffix to it, that is halide, the alkyl halide becomes the common name of that haloalkane, or the halogen substituted alkane. Normally that is how you would give the common names of these haloalkanes. But when you come to the Iupac nomenclature, if you remember, in Iupac nomenclature there are 5 parts to a name, and how we systematically give the name of a compound. What are the 5 parts? The 5 parts are the word root, the primary suffix, the secondary suffix, the primary prefix, and the secondary prefix. That is it. Every Iupac name has 5 parts. The word root tells you the number of carbon atoms. So you see, you choose the longest chain and you see the number of carbon atoms, the maximum number of carbon atoms in the longest chain, and that becomes the parent hydrocarbon, and that gives you the word root. For example, in this first compound, you have CH3, CH2, CH2Br, right? So the common nomenclature here is normal propyl bromide. But in Iupac nomenclature, when we are going to name this, we are first going to focus on the word root. And the word root tells us to find the longest chain. It has 3 carbons. So for 3 carbons, the word root is prop. For 1, it is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, and so on. So here the word root would be prop. So word root gives you the number of carbon atoms, right? Cn, that is the number of carbon atoms. Then comes the primary prefix. The primary prefix tells you whether a compound is cyclic or is it an alicyclic. That is it an open chain compound or is it a cyclic compound? And primary prefix is only used in the case of cyclic compounds. If the compound is cyclic, you will add the prefix cyclo to it. And if it is not cyclic, it is a straight chain compound, you skip the primary prefix. So any part that is not present, you do not name that. And obviously the other 5 parts you would, all the 5 parts you would focus on. So the word root would always be there. Then the primary prefix will tell you, you will write primary prefix only if the compound is a cyclic compound, and the prefix that you would be using would be cyclo. The secondary prefix is usually for a substituent, and a substituent is a kind of a weaker functional group, you could say, or a functional group which is lower in importance, and therefore it is being given the position of a substituent and not the functional group. The functional group is that most reactive part or a group that is attached to the hydrocarbon. So for the secondary prefix, you will have a substituent, and halogens are treated as substituents. Although it may act as a functional group, it is never kept so high up in preference that it would be acting as the suffix. It is always written as the secondary prefix. And that is where you'll have the halo compounds. I'm writing Cl, it would be X, right? Then comes the primary suffix. So the primary suffix tells you about the saturation of the carbon atoms of the carbon chain. If it is all single bonds, it is an ane. If it is a double bond, it is an ene. If there's a triple bond, it's an ine. So the primary suffix tells you whether it's an ane, ene or ine. Now, after this, if you have a functional group too, then you drop the E in the end and you add those functional groups. The suffixes of the functional groups, for example, for alcohols you have OL, that is, let's say it is methane, and if you have the functional group OL, that is OH to it, it will be called methanol. And you will drop the E and the spelling will become, the word root would be meth, M-E-T-H. It is not cyclic, therefore you skip this. It has no other prefix, that it has no substituent, it only has a functional group, that is all. So it becomes meth and all. And you drop the E because you cannot have two vowels together. So that is how you write an IUPAC name. This is just a brief idea of it. I would encourage you to watch those videos and see how, and go into details how the IUPAC nomenclature is done. Using this basic information, let us take this example of about 9 compounds and see how they are named. Now this was CH3, CH2, CH2Br. And I told you that in common nomenclature, this compound would be known as, it is normal propyl bromide. N stands for a simple chain, right? So it's a simple straight chain would be a normal. There are 3 carbons, so which alkyl group is it? It is propyl group and bromide. But for IUPAC nomenclature, the word root would be prop, and is it cyclic? No, so no primary prefix. Is there a substituent? Yes, bromide is the substituent. So it would be bromo, and it is propane. Prop is the word root, and are they saturated? Yes, every carbon is forming 4 bonds. So it is a saturated hydrocarbon. The suffix that you would be using would be ane. So the name of this compound would become, now where is the bromide, that is bromine atom attached? The bromine atom is attached to the first carbon. So according to the lowest locant rule, you will have the name of this IUPAC name of this compound would be 1-bromopropane. The bromo is attached to the first carbon, it is prop, and it is an ane because it is saturated. So the name of this compound becomes 1-bromopropane. Come to the second compound now. CH3CH, CH3 and Cl. The chlorine is attached to the second carbon, not to the terminal carbon. When you say terminal carbon, it means the last carbons. So it is attached not to the last carbon but to the middle carbon or any carbon in the chain if this was a longer chain. So whenever you have such compounds where carbon does not form a simple chain, it has one branch, it forms a methyl group or the substituent which is attached to a branch, it is known as an iso compound in the common nomenclature. So this becomes iso, it is iso, which means that the chlorine is present on a branch and the compound is propane, so we will use it as one hydrogen less makes it propyl group, so it would be isopropyl chloride would be the common name. But what would the IUPAC name be? What is the word root? There are 3 carbons, so it is prop. It is saturated, so it is ane, and the chloro is a substituent, so it will be written as chloro. It is not cyclic, so primary prefix will not be there, and the chloro is at the second carbon, so it would be 2-chloropropane. So the name of this compound would be 2-chloropropane. And remember, in IUPAC nomenclature, the first alphabet is a capital and all other alphabets are small, and whatever parts are there in the name, they are always joined together unless there is a locant that has to be put. That is, you have to specify the number of carbon where that particular group is present or where the ane is present. In that case, you will have a separation with the help of hyphens. We'll do that. That is the next example. So this is 2-chloropropane where C is capital. That is the IUPAC nomenclature. Let us now come to the third compound. The third compound is CH3CH. There's a branch, CH2Cl. If you remember, I told you whenever there's a branch and there's a methyl group or a substituent attached to the branch, we call it an iso compound. So this is iso. And how many carbons are there? There are 4 carbons. Since there are 4 carbons, it becomes butane. If you remove one hydrogen, it becomes butyl. So according to common nomenclature, this is iso because it has a branch. It is butyl because it has 4 carbon atoms, and chlorine is written as the chloride as a suffix. So this is isobutyl chloride in common nomenclature. But in IUPAC nomenclature, how would we name this? What is the word root? The word root has to be the longest chain. Here the longest chain without branching. What do you have? The longest chain has 3 carbons, and this is a branch. If you have a tree from the roots to the top of the tree, that is one tree, and anything on the side is only a branch, so that doesn't make the main trunk of the tree. So you have this compound, this is propane, and it is propane and it is chloropropane, and there is a methyl group attached to the propane. So how will we name it? The word root would be prop. Is it cyclic? No. Is it chloro? Yes. So the first carbon has chloro because any substituent would get more importance than the methyl group. So this would be the first carbon. Wherever a functional group attaches, we try to give that carbon the lowest locant. So this one would be the first carbon. This is carbon 1, carbon 2, carbon 3. So you have chlorine attached to carbon 1. So this becomes 1-chloropropane, but there is a methyl group also attached to it, right? And the methyl group is attached to the second carbon. And methyl and chloro, both are substituents. So this has 2 substituents. If it has 2 substituents, 2 methyl and 1 is chloro. And when you have 2 substituents, you would always write the one which is alphabetically smaller, lower, first, and then the one which is higher in alphabet, and then write the name. So in this case, C is for chloro and M is for methyl. So C will come first. So we write 1-chloro, 2-methyl-propane is the IUPAC name of this compound. Come to the next compound now. Now this has CH3C, 2 branches, CH3 and CH3 above and below it, then CH2, CH. So the main chain here is this one, right? And this would be treated as the first carbon because the chloro is attached to this. But that is, I'm talking of the IUPAC nomenclature. Let us first talk of the common nomenclature. This has got 5 carbons, 1, 2, 3, 4, 5. So this is a pentyl group. And since it is branched like this, one of the carbons is making 4 bonds, that is 4 separate bonds with 4 carbon atoms. Such a compound is known as a neo compound. So it would be using the prefix neo. And since it has got 5 carbons, it is neopentyl, and the chlorine would be chloride. Neopentyl chloride would be the name of this, common name of this compound. And in IUPAC nomenclature, the longest straight chain is this one. These 2 are treated as branches. So the parent hydrocarbon or the word root becomes prop because it has only 3 carbon atoms in the main chain. So it is propane and it is saturated. So it is propane. And is it cyclic? No. So no primary prefix. Secondary prefix is chloro. Plus there are 2 other secondary prefixes. That is methyl and methyl. When you have 2 methyls, you would call it a dimethyl. Right? So in any case, chlorine is lower in alphabet than D of dimethyl, so or M of the methyl. Therefore, we'll write chloro first and the methyls will be written later. But what are the locants that you would give them? What are the numbers that you would give them? 1-chloro, 2,2-dimethyl, right? So what is the name here? 1-chloro, 2,2-dimethyl, prop because it has 3 carbons, ane because it is a saturated hydrocarbon. So that would be its IUPAC nomenclature. Now, let us come to the haloarenes. You have this benzene ring and bromine is attached to the carbon of the benzene ring. So it is a ring substituted hydrocarbon. And in this you have the common nomen. In such a case where you have a ring substituted, mono substituted hydrocarbon, usually the common name and the IUPAC name for such compounds is the same. So this is bromobenzene in common nomenclature. For arenes, we do use the halogen as the prefix. So this becomes bromobenzene, and IUPAC nomenclature, of course, is the same, that it still is bromobenzene. But if you have a di-substituted compound, in di-substituted benzene, you can have 3 options. And if the di-substitution is of the same element, like bromine, 2 bromines or 2 chlorines, whatever. So in this di-substituted, you see for the example 6, this is benzene, and if this is the first carbon and this is the second carbon, the bromines are attached to adjacent carbon atoms. In the example 8, I've written 8 and 9 together here. In example 8, you see, I'm skipping this example 7. I should have written it in the end, but I did not want to correct it. I just thought I'll explain 6, 8, 9, and then we'll do 7. So in 6, you have the 2 bromines attached to 2 adjacent carbon atoms, that is 1 and 2 position. In 8, you have bromine attached to carbon 1 and carbon 3. Carbon 2 is empty. So the substitution is, the locants are 1 and 3. And in this compound, you have the 2 bromines attached at 1 and 4 carbon. So there are 3 possibilities in the case of di-substituted benzene compounds. One is a 1,2 substitution, one is a 1,3 substitution, and one is a 1,4 substitution. Now you might say, why doesn't this go here then? Then you would have a 1,5 substitution. No, you would not have a 1,5 substitution, because then you would count from the other side. And from this side, when you count this, it would be the 3rd carbon, so it is the same thing. So we only count up to the one extreme on one side, and that gives us the maximum number of options in nomenclature while we are naming them. Because we always count from that direction where we will get the lowest locants. So here you have 1,2 substitution, 1,3 substitution, and 1,4 substitution. In common nomenclature, 1,2 substitution is known as the ortho substitution. 1,3 is known as meta, and 1,4 is known as the para substitution. So these are the names that are given when you have the common nomenclature. That is, ortho is O, it is the alphabet O represents the ortho, so it is ortho dibromobenzene. So there are 2 bromos and it is a benzene. So ortho, for 1,3 position, it will be meta, so it is substituted by M, so you write the prefix M, dibromobenzene, and when you have 1,4 position in common nomenclature, you will call it para, and the alphabet P is used, small alphabet. Remember, P, M, and O are the small alphabets, they are not capital alphabets. A hyphen and dibromobenzene, meta dibromobenzene, and para dibromobenzene, these are the common names. But when we come to the IUPAC nomenclature of di-substituted compounds, we again follow the same rule as we have been doing, that for 1, this would be 1,2 dibromobenzene. We will specify the locants. We do not use the expressions ortho, meta, and para in IUPAC nomenclature. So this would be 1,2 dibromobenzene, this one would be 1,3 dibromobenzene, and this would be 1,4 dibromobenzene. Or ortho is 1,2 dibromobenzene, meta dibromobenzene is 1,3 dibromobenzene, and para dibromobenzene is 1,4 dibromobenzene. Now let us come to the example 7. This is a tri-substituted compound. There are bromines present on the 1st carbon, the 3rd carbon, and then 4th, 5th carbon. You would call it the 5th carbon. Why? Now when you count, whenever you count and you're naming a compound and you've started counting from one direction, you can't change the direction while naming it from one direction. So you have to go on till you have added all the substituents. So this becomes 1, 3, and this position becomes 5. So this would be, and if you look at this molecule, it looks symmetrical. Therefore, in common nomenclature, we call it SIM, or symmetrical tribromobenzene. It is symmetrical, means all the bromines are attached on carbons so that it gives it a symmetrical structure. Obviously, there would be symmetry only if all the 3 bromines are present on alternate carbons. But in IUPAC nomenclature, we always specify the locants. If this is carbon 1, this is carbon 3, and this is carbon 5. So we write it as 1,3,5 tribromobenzene. So this is how you would write the nomenclature of these compounds. Alright, let us now name a few more compounds. Look at this first example. This is example number 10. The compound is CH3CHCl2. Now, whenever you have the dihalides for open chain compounds, now look at this, this has got the 2 halogen atoms, that is 2 chlorines attached to the same carbon atom. I told you in part 1, I guess, or in the previous video about this, that when you have the halogen atoms attached to the same carbon atom, they are called gem dihalides. And when you have halogen atoms attached to 2 adjacent carbon atoms, such compounds are known as vicinal dihalides. There is another type of common nomenclature which is usually given to such gem dihalides and vicinal dihalides. They are known as the ethylidene chlorides or the ethylene dichlorides. Ethylidene, D stands for 2. So ethylidene will not have dichloride. It is ethylidene chloride. But that is usually, ethylidene is used for gem dihalides. So this is a gem dihalide, that is CH3, CH, Cl2. Both the chlorine atoms are attached to the same carbon atom. Therefore, it is a gem dihalide, and usually in common nomenclature we use ethylidene chloride for this. And for the vicinal dihalide, in common nomenclature they are known as the Wick dihalides. You write these are the two halogen atoms attached to two adjacent carbon atoms, and it is ethane, so it is known as ethylene dichloride. For IUPAC nomenclatures of gem and vicinal, we do not use any such other names. We follow the same rules. And what are the rules? This compound, what is the word root? There are two carbon atoms, so it is an ethane. It is saturated, so it is ane. It is ane because it is saturated, it is not cyclic, therefore there is no primary prefix, but there are two chlorine atoms, so it is a dichloro substituted compound. And you have to give locants of both the chlorines. So both the chlorines are attached to the same carbon, and we will count this as the first carbon, therefore this would be 1,1. Both the chlorines are attached to the first carbon, the 1,1 dichloro, and it is ethane. So that would be the common nomenclature. 1,1 are the locants of the substituted element, that is chlorine, or the substituent. 1,1 dichloroethane would be the IUPAC name of this compound. And for the vicinal dihalide, what would the IUPAC name be? This is also the same. It is ethane, so the word root is ith. It is saturated, so it is ane, and it has also got dichloro, but the locants of the two chlorines are different. One chlorine is on the first carbon atom and the second chlorine is on the second carbon atom. So you would say 1,2 dichloroethane would be the IUPAC name of this compound. Come to example 12 now. CH3, CH2, CH, Cl, CH3. Now we have a chlorine which is present not on the terminal carbon, it is present somewhere inside the chain. So here it is present on the second carbon. So what would be the common nomenclature for such compounds? Whenever you have the substitution not on the outermost carbon but somewhere within the chain, it is or the carbon adjacent to the terminal carbon atom, such compounds are known as secondary. Such a substitution is known as secondary. Another way of saying it is that if the alpha carbon is the carbon to which the substituent is attached, that is chlorine is attached to the alpha carbon, so this becomes the alpha carbon. If alpha carbon is attached to only one other carbon atom, that alpha carbon is a primary alpha carbon. If it is attached to two other carbon atoms, it is a secondary alpha carbon. So this, and if it is attached to three other carbon atoms, it would be a tertiary carbon atom, tertiary alpha carbon atom. So based on that, in the common nomenclature, you would call this the secondary. And how many carbons are there? There are 4, so it is a butyl group. So it would, and since it is chlorine which is attached to it, it would be a secondary butyl chloride would be the common name of this compound. But how would you write the IUPAC nomenclature? The rules don't change there. The word root is 4 because there are 4 carbon atoms in one chain. So it is but, it is saturated, therefore it is ane. It has the substituent chlorine attached to it, so we will write chloro. It is not cyclic, so primary prefix is not there. So it is chlorobutane, but the chloro is attached on the second carbon atom. So we write its name as 2-chlorobutane. So the name is 2-chlorobutane. The first letter of the name is always a capital, just like the name of your name. Your name, the first alphabet is always a capital. So this becomes 2-chlorobutane in IUPAC nomenclature. Example 13. In example 13, there are two branches, two methyl groups attached to the second carbon atom. So you have CH3, CH3 forming the main chain, and two methyl groups attached to the second carbon atom, and the bromine is attached here in the end to one of the carbons. Now these two are methyl groups according to IUPAC nomenclature, but according to common nomenclature, this compound has 5 carbon atoms, therefore it is forming a pentyl group, right? And it is a bromopentyl. And since the carbons are branched, how would you name them? Wherever you have a compound where one of the carbons is attached to 4 other carbon atoms, that compound is known as a neo compound. The prefix we use is a neo, is neo. So this becomes a neo, 5 carbons, so it is pentyl, and since bromine is attached, we call it neopentyl bromide. But again, IUPAC nomenclature, we would take the parent chain as to be this one, and this has only 3 carbon atoms. These 2 methyl groups will be treated as branches. The bromine group is the substituent which is attached to the first carbon. We will count from this direction because that way we'll get the lowest sum of locants. If we had counted from this side, this would be carbon 1, 2, 2. The locants would be 2, 2 and 3. We don't want that. If we count from this side, we get 1. The locant of bromine is 1, and for methyl groups it is 2, 2. So we'll count from this side. So this becomes propane. Prop is the 3 carbon atoms. The word root is prop. It is saturated, so it is ane. It is not cyclic, so we skip that. The primary prefix, the secondary prefix is bromo and methyl and methyl. So there are dimethyl and bromo. So again, how would you name this when you're writing the names of these the prefixes? When you have more choices, more than one, then you go by the alphabetical order. So B comes before D and B comes before M also. So you would say 2-bromo. Oh, it's not 2-bromo, it should be 1-bromo. 1-bromo, 2,2-dimethyl propane would be the name of this compound. The bromine is on the first carbon atom, 2,2-dibromo propane. Now let us come to example 14. In example 14, again, there are, now this is a little tricky. The carbon which is attached to 3 other carbon atoms, the bromine is directly attached to this carbon atom. It is not here. Here, bromine was attached to a regular CH2 group, and that CH2 group was attached to a carbon which was attached to 3 other methyl groups, making it a neo compound. In this case, this alpha carbon is a tertiary carbon. Just as we took here the alpha carbon, this alpha carbon was a secondary carbon. It was attached to 2 other carbon atoms. But here, the alpha carbon atom is attached to 3 other carbon atoms. Therefore, it becomes a tertiary carbon atom. So this group will become, there are 4 carbons, so it is a butyl group. Since it is tertiary in nature, since the alpha carbon is tertiary, we'll call it tertiary butyl bromide in common nomenclature. But when you come to IUPAC nomenclature, what will be the longest chain? These 2 carbons would be taken as the longest chain, or rather you would go like this. You would go this way. So this becomes your longest chain with just 1 methyl group and 1 bromide group, right? So you will say this is propane, and the second carbon has got what? Both the bromine and the methyl group. So you'll say 2-bromo, 2-methyl propane should be the name. Yes, 2-bromo, 2-methyl propane will be the IUPAC name of this compound. Example 50. CH2 double bond CHCl. So now we have unsaturated hydrocarbons, and the halogen has been attached to an unsaturated hydrocarbon by replacing one of the hydrogens of that compound. So this is, the word root is, I'm straight away coming to the IUPAC nomenclature. I'll first come to the common nomenclature. Whenever you have the group attached to a carbon which has a double bond, the carbon or the alpha carbon which has a double bond would be a vinyl group. But if the alpha carbon is attached to another carbon which is sp2 hybridized, or which has a double bond, in other words, the carbon which is attached to the halogen is sp3, it is forming single bonds, but the carbon which is attached to this one is sp2, or it has a double bond. Such a compound in common nomenclature is known as the allyl compound. So this is vinyl chloride and this is allyl bromide, right? So in common nomenclature this can be a little tricky because there are no set of rules and common rules that will be followed in common nomenclature, and that is the reason why we had to, we still use them, because at many places the common names would be used, but The IUPAC nomenclature is the one that is systematically followed. So even if you do not get the common name, the IUPAC name will always help you find the right compound. But since you are students, you're not scientists, you need to have an idea of both types of nomenclature. So whenever you have the substituent attached to a carbon which is sp2 hybridized, or which has a double bond, in other words, it would be a vinyl compound, vinyl substituted compound, so it is vinyl bromide. And if it has a carbon which itself is sp3 hybridized but joined to another carbon which is sp2 hybridized or has a double bond, it would be an allyl bromide. Let us now write their IUPAC names. There are 2 carbon atoms, so the compound is eth. It has an ene, so it is ethene. Now there is one thing that you have to remember whenever you are writing down the names of haloalkenes or haloalkynes. The halogen, as I told you, is a substituent. And substituents are always treated to be less important than the suffixes. So ane, ene and ine are more important than the halo group. Whenever you have to assign the locant, you will assign the lower locant to the position of the ene and ine. Ane, of course, you need no locants there. So you will have to assign a locant first to the ane, ene or ine. Ane doesn't need a locant. So you will have to first give the locant to the ene and ine, and then you will give the locant to the substituent, which is the prefix. A prefix is not treated to be is not given preference when you are naming it. Therefore, in this case, of course, in the first example, this is ethene, and on the first carbon itself, there's a double bond, so you don't have to choose the locant. It is if the locant is 1, we can always avoid it unless you are repeating it, like we did in dichloro here. Here we needed the locants because you have to specify where exactly is each chlorine present. But if you have only 1 chlorine and only 1 alkene, it is obvious if we are not giving it a locant, that has to be the first carbon. So both the first carbon here has chloro also and it has ene also. So this is ethene and it is chloroethene. The substituent is chloro, so it is chloroethene, and assumed that both the locants are 1 here for the chloro and for the ene. But here is where the preference will come into play. This is a bromine which is attached to the carbon, and this is an ene, a double bond. So when we are numbering it, we would like to count from this side, because the ene is more important. Ene is a suffix, and a suffix is any day more important than a prefix, right? So you will start numbering, counting from here. The first carbon has the ene and the third carbon has the bromo. So word root, it is prop. And is it ene or ine? It is ene. It is propene, right? And if I don't write the locant, where is the ene? Obviously on the first carbon atom, because there is only 1 ene. So I will write propene is my compound, and it is substituted with bromo. So bromo is on which carbon? Bromo would be, if this is 1 carbon, then 2, 3, bromo is on the third carbon. So the name of this compound would be 3-bromo-prop-ene or 3-bromo-propene, right? Just a few more problems before I finish this table, and then in the next video we'll be doing these solved examples and the in-text questions. Give me a moment to write them down now. Alright, so now this is the last set of examples that we will be doing for this video, the compounds that we will be naming. This is example 17. Look at this example. It has a benzene ring, and to 2 adjacent carbon atoms, to 1 carbon atom is attached chlorine and to the other is methyl group. In common nomenclature, whenever you have the methyl group attached to the benzene ring, we call that as toluene. And this word toluene has been adopted by the Iupac nomenclature also. So whenever you use the term toluene, it means methyl benzene, and whenever you use the term toluene, it means that you are assuming that methyl group to be the first carbon atom, to be attached to the first carbon atom. So toluene is actually methyl group attached to the first carbon atom. Remember that whenever you use it in the Iupac nomenclature. Otherwise, if you feel that there is another group that is more important than the methyl group, you would not like to use the term toluene. You would rather name it as the benzene substituted compound. I'll come to that later. But in common nomenclature, we always call it a compound which is toluene. So toluene, this is, and since chlorine is attached to the next carbon itself, such substitution, 1,2 substitutions in common nomenclature are known as ortho substitutions. So this is ortho, it means ortho, that 1,2 substitution is there. Chloro, it means that at the second position is chloro, because toluene means that methyl is attached to the first carbon atom. So the chloro is attached to the second carbon atom. So it will be ortho, chloro, toluene. In IUPAC nomenclature also, you could call it toluene. So it would, instead of writing ortho then, what would you write? You would write that if this is toluene, this becomes the first carbon and chlorine, the locant for chlorine becomes the second one. So you would write it as 2-chlorotoluene. You will not write ortho. Excuse me. Now when you do not want to use the term toluene, then you would go by the normal IUPAC rules and you would take this as benzene. Chlorine is a substituent and methyl group is also a substituent, but chlorine is more like a functional group and methyl group is not as strong. Therefore, we give chlorine more importance. Therefore, the locant would go to chlorine. The carbon which has chlorine will become the first carbon and the carbon which has methyl group will become the second carbon. So now when we bring it, when we name it, it is a benzene and it is 1-chloro, 2-methyl. And again, when you have to name both of them, chloro is lower in alphabet, so we'll write chloro first and then we'll write methyl. So it will become 1-chloro, 2-methyl benzene. The next example here, example 18. It has the chlorine attached to the methyl group which is attached to the benzene ring. So it is a side chain substituted compound. Whenever you have a side chain substituted compound in IUPAC nomenclature, we will take this methyl group to be the parent hydrocarbon and the benzene group will be taken as a substituent. Anything that has the functional group, that part becomes the main part or the main skeleton of the compound or the parent hydrocarbon as we call it. So the parent hydrocarbon here would be methane, and although this has 6 carbon atoms, that only becomes a substituent in IUPAC nomenclature. In common nomenclature, we call this benzyl chloride. This compound is known as benzyl chloride in common nomenclature, and in IUPAC nomenclature, what is the word root? Meth, because the parent hydrocarbon has only 1 carbon atom, so it is meth, it is ane, and it has 2 substituents, that is benzene. Whenever it is a substituent, it is known as the phenyl group. So the prefix is phenyl. So it is phenyl and chloro. All substitutions are on the same carbon atom because it has only 1 carbon atom. So C and P, alphabetically which is smaller? C. So you will say chlorophenylmethane. So the name would be chlorophenylmethane. There should be no gaps. It should be one continuous word. Example 19. The compound is CH2Cl2. CH2Cl2 is, if you see again, there is only 1 carbon atom and both the halogens are attached to the same carbon atom. Whenever you have dihalides where the carbon is attached to the same carbon atom, the halogens are attached to the same, both the halogens are attached to the same carbon atom, it's just known as a gem dihalide. So this is a gem dihalide. Common nomenclature would be methylene chloride. And IUPAC nomenclature, it is a dichloromethane. So meth is the parent hydrocarbon, ane because it is saturated. There are 2 chloros, so it is dichloro. Both of them have locant 1, so there is no need of writing the locant, but you could write 1,1-dichloromethane. And the reason why we do not care about writing the locant here is because there is only 1 carbon atom and the substitution obviously has to be on that carbon atom, it can be nowhere else. So it is dichloromethane. Come to this now. This is trichloromethane according to IUPAC. There are 3 chlorine atoms, tri-substituted, 1 carbon, meth, ane, it is saturated, so it is trichloromethane. But in common nomenclature, this compound is known as chloroform. So no rules of naming it there, it is just a name given to the compound. This compound is known as chloroform. And if it was CHBr3 instead of chlorine Cl3, if it was Br3, the common name would be bromoform, and that is its common name, bromoform. And in IUPAC nomenclature, it is tribromomethane, right? Meth, parent, ane is it is saturated, and 3 substitutions are bromines at the same carbon atom, so tribromomethane. Then comes CCl4. CCl4 is a little controversial compound because it has no hydrogen, and hydrocarbons are compounds which have both carbon and hydrogen. So some scientists believe that CCl4 does not belong to organic compounds, yet it can be derived from them, and organic compounds can be derived from CCl4. Therefore, it very much is an important part of organic chemistry, and therefore we study this and we name it also. In common nomenclature, this is known as carbon tetrachloride. And in IUPAC nomenclature, we will assume that all the 4 chlorines have substituted the 4 hydrogens of the methane. So 1 carbon, meth, it is saturated, ane, and there are 4 chlorines, so it is tetrachloromethane. Tetrachloromethane. And now the last example that we have, CH3, CH2, CH2F. In common nomenclature, fluorine, the halogen, is attached to a carbon, a straight chain. So this is a normal, and in the end of the chain, so it is a normal propyl fluoride. There are 3 carbon atoms, so what group is it? It is propyl group, and it is a fluoride. So in common nomenclature we call it N-propyl fluoride, but in IUPAC nomenclature it is propane, and there is fluorine present, so we will call it fluoropropane. And since the substitution is on the first carbon atom, we can call it 1-fluoropropane, or we could skip the locant, which obviously means that it is the first carbon atom. So these were the examples of nomenclature that I wanted to do with you in this video. In the next class, I would be doing the solved examples and an in-text question for you. So with this, I'll wrap up this video. If you felt it was helpful, please give me a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.